All right, let's dive into a molecule that is literally all around us in every single breath we take: carbon dioxide. We're going to explore how this totally invisible gas connects our own bodies to the cars we drive and what that all means for the planet. So let's kick things off with a little riddle. What could the air you just breathed out possibly have in common with the exhaust coming out of a car? It sounds a little weird, right? But the answer connects everything, and it's all thanks to one little molecule: carbon dioxide. To really solve that riddle, we first need to properly meet the main character of our story. So what exactly is carbon dioxide? Okay, at its most basic level, carbon dioxide, or CO2 as you've probably seen it written, is just what it says here: a gas you can't see or smell. It's not some weird chemical from a factory. It's a totally natural part of the air that we're all breathing right this second. And this is where it gets really cool, because CO2 is not the villain of the story. It's actually a core part of the rhythm of life itself. We breathe it out, and plants breathe it in to grow. You remember photosynthesis from science class? That's it. It's a key piece of the planet's whole operating system. Yeah, it's a huge part of this much bigger system, the carbon cycle. Think of it like a constant flow, an exchange of carbon moving between the land, the oceans, all living things, and the air. The bottom line is, it's supposed to be here. So, if it's natural and part of this balanced cycle, where does the problem come in? Well, to get that, we need to look deep, deep underground at where we get most of our energy. We call them fossil fuels, and the name gives it away, right? They're literally made from the fossilized stuff left over from ancient plants and animals. We are talking millions upon millions of years of life and sunlight, all squished down and stored deep in the earth. It's like a massive planetary battery that's been charging up for eons. And you'll definitely recognize the big three. There's coal, there's oil, which gives us petrol and diesel for our cars and trucks, and then there's natural gas. These are the absolute workhorses of our modern world. So here's the most important thing to get. All of these fuels are basically different packages for the same thing. They're just huge, concentrated stores of ancient carbon that was locked safely away from the atmosphere for millions of years. But of course, we don't just leave that carbon locked away, do we? Nope. We dig it up because we want all that energy it's holding. And that brings us to the moment it all gets released. The way we get the energy out is just by burning it, and the chemistry behind it is surprisingly simple. You start with the carbon from the fuel, you add some oxygen from the air, and then you add heat. And that simple combination kicks off a reaction that creates, you guessed it, carbon dioxide. This little equation right here sums up the whole shebang. One atom of carbon that's been buried for ages grabs two oxygen atoms from the air we breathe. And boom, a brand new molecule of CO2 is born and released into the atmosphere. And this really captures the trade-off perfectly. On one side, we get this huge burst of energy that we use to power our lives. But on the other side, the byproduct, the exhaust from that reaction, is carbon dioxide gas. Now, for most of human history, this whole process wasn't really a problem. But in the last couple hundred years, the sheer scale of our energy use has changed everything. It's led to what we call our growing carbon footprint. What this all means is that we're now releasing that ancient stored carbon at an absolutely incredible speed. Every time we drive a car or flip a light switch that gets its power from a coal plant or heat our homes with gas, we are setting off that exact same chemical reaction, just adding more and more CO2 to the air. You know, I want to pause on this last point for a second because deforestation is a real double whammy. It's not just that we release the carbon stored in the trees when we cut them down and burn them. We are also destroying the very things that are best at pulling CO2 out of the atmosphere. It's like trying to bail out a sinking boat, but you do it by punching another hole in the bottom and throwing your only bucket overboard. It makes the problem worse from both sides. So what's the actual consequence of all this extra carbon dioxide in the air? Well, probably the best way to picture it is to think of the Earth having an invisible blanket. This blanket is made up of what scientists call greenhouse gases, and CO2 is a really big one. These are just certain gases in our atmosphere that are incredibly good at absorbing heat from the sun and trapping it instead of letting it just bounce back out into space. Now, CO2 isn't the only one. You've probably heard about methane too, but carbon dioxide is the one we release in such gigantic quantities that it's having the biggest overall effect on this whole heat trapping process. And this brings us to the most important point of all. The greenhouse effect itself is natural. It's a good thing. It's what keeps our planet warm and cozy enough for us to live here. The problem is that by adding billions of tons of extra CO2, we're thickening that natural blanket. And just like when you're in bed, if you throw another, thicker blanket on, what happens? You trap more heat. And that's what's happening to the planet. Which brings us right back to the beginning. Carbon dioxide is natural, it's absolutely essential for life, but the enormous amount of ancient carbon we've dug up and released is knocking a very delicate system out of balance. And that leaves us with maybe the most important question of our time. Since we know CO2 is supposed to be here, how on earth do we find the right balance again?